Okay, so maybe you were able to pick up from the introduction there that some things are projectiles, other things are not. So what makes a projectile projectile? Well, a projectile is anything moving through the air while only the force of gravity is acting on it. So if you noticed, some of the things that were not projectiles were a piece of paper, a paper airplane, because too much air resistance there, okay? Other things that were not projectiles were things that had motors, okay? They can propel themselves. All right, so a projectile, something known as gravity acting on it. The trajectory is the path the projectile takes. You will notice the projectiles take a parabolic path. Sometimes we launch them only horizontally. So it starts here and we launch it so it goes exactly horizontal. And then gravity takes over and you end up with half a parabola. Okay? Other times we might launch it so that it fires up at an angle, and then we might get a parabola that looks something like this. It goes up at an angle, comes back down. Okay? But this path is called the trajectory. Okay? The horizontal and vertical movements of a projectile are independent of each other. That means they do not affect each other. Okay? The horizontal movement is not going to affect the vertical movement, and vice versa. Also, the horizontal velocity of a projectile is constant. Gravity doesn't pull us sideways, left or right, okay? Gravity pulls us in one direction, down, towards the center of the earth, okay? So we're not going to have any acceleration going to the right or going to the left, okay? On the other hand, the vertical motion of a projectile is accelerating, and it's accelerating downward because of gravity. So as it goes down, it will speed up. So they're independent of each other. That means that when we go to solve, we are going to have equations for the x direction, the horizontal direction, and for the y direction, the vertical direction. Notice the x direction only has one equation. That's because there's no acceleration in the x direction, and therefore we don't need to use any of the equations with acceleration. Also notice that now my velocity here has a little subscript x. That's to denote that this is the x direction velocity. Similarly, these have y's to denote that they are the y direction velocity. In the y direction, we have significantly more equations. That's because in the y direction, there is acceleration, and that acceleration is due to gravity. So we even know the value of that will be negative 9.81. We also will have a velocity that's changing, so we'll have a final and initial. So you notice the y direction is more complex than the x direction. So what does the path look like? What's the trajectory look like? Well, if I have a ball and I launch it exactly horizontally, the trajectory will look similar to this. Okay, so what is that? Well, let's take a look. In the x direction, the ball went 5 blocks in the first time period, maybe a second. The ball went 5 blocks in the second time period, 5 blocks in the third, 5 blocks in the fourth. It's moving at a constant velocity in the x direction. Okay? That's why we don't have any acceleration over here. Go back. If we look at the y direction, in the y direction, the ball is moving down a couple blocks. More, and more. Okay, so some of the things we know when horizontally launched. The velocity given is Vx because we're throwing the ball horizontally. We're not throwing it up. So therefore, when we start, the initial velocity when it's in my hand is only going in the horizontal direction. Okay, as soon as I let go of it, it's going to start having some velocities that are increasing as it goes down, okay, in the y direction. But that x direction velocity is what's going to be given if it says it's horizontally launched. It's all in the x direction, and that's going to stay constant throughout the problem. Next. The initial velocity, VIY, the initial velocity in the y direction, so the initial vertical velocity, is 0. Okay? We're launching it this way. I'm not giving it any velocity speed going up, any velocity going down. I'm not throwing it in those directions. I'm throwing it this way, so it's starting off as if it were dropped. And then as soon as I let go, it does start to gain some velocity in the downward direction due to gravity. Leads us to the next one. What's causing this acceleration? Gravity. Therefore, it has a value of negative 9.81 meters per second squared. Okay, the acceleration in the y direction. Final hint, if you can't solve for what you need, so you can't have, the equation has more unknowns than one. For time in one of the equations where time is the only variable you do not know, and then go back to the other variables, plug the time in, and solve for what you need.